Hello viewers, welcome to this video. In this video we will be looking at the November 2016 Science Paper 1 Section B Question 5. Question 5 reads, Figure 5.1 and Figure 5.2 show the displacement distance and the displacement time graphs respectively. The graphs are for a water wave in a Ripo tank. Figure 5.1 and Figure 5.2 show the displacement time, the displacement distance, and the displacement time graphs respectively. The graphs are for a water wave in a Ripo tank. All right, so let's look at those graphs. So this is the distance time graph. So this is the displacement distance graph, and this is the displacement time graph. Okay, so the distance there is in centimeters, the time there is in seconds. All right, let's go to the first question. The first question is saying, state the wavelength of the wave. State the wavelength of the wave. So wavelength, distance. The wavelength is the distance between two successive points on a wave. The distance between two successive points on a wave. Okay, so if it is distance we are looking for, then we are going to use the displacement distance graph. And to find the distance between two successive points, okay, what we do is, okay, the wave is starting from here at 0, okay, and when it reaches 1 here, one wave has not yet been done, but it is half a wave. Okay, when it reaches 2, it's almost starting again. Okay, it's almost starting. Okay, it's starting actually. Yeah, so this is one wave. That is one wave. Okay, it's one wave. And how long is that single wave? It's 2 centimeters. It's 2, so it's 2 centimeters. Now, depending on where you're coming from, you can record it as 2 centimeters, or you can convert it to meters. And in meters, I'll just use this C is 10 to the power negative 2. So I'll say it's 2 times 10 to the power negative 2 meters. So that is the wavelength. 2 times 10 to the power negative 2 meters. And if you convert, if you use 1 meter to represent 100 centimeters, you may also find something like 0.02 meters. It's one and the same. It's one and the same. All right. Then we go to B. State the period of the wave. State the period of the wave. So the period is time. Period is time. So we move from the distance time to the from the displacement time to the from the displacement distance to the displacement time. Okay, the time here is in seconds. What is period? Period is the time taken for the generation of one complete wave. So we are looking for the time it takes to produce one complete wave. Again, we start. T is equal to 0 is there. When we reach T is equal to 0.02 seconds, the wave is half made. When we reach 0.04, we have one complete wave. So from there to there, we have one wave. So we have one wave. So the time taken to generate one wave is our period, and the period is 0.04 seconds. So we come and record 0.04 seconds. So that is our period. All right. So we proceed to C. C is saying, what is the speed of the wave? What is the speed of the wave? So the speed of the wave is basically, if you want this, the wave is moving at a constant speed and it's not accelerating. So we can say speed is equal to distance over time. Okay, the distance covered by one wave over the time it takes to to cover that distance. So we can equally say that this is speed will be equal to the wavelength divided by the period. So I know this may seem to be confusing. However, if you look at this critically, you find that frequency is equal to 1 over period. Okay, and the wave equation is V is equal to frequency times wavelength. Now, what is our frequency? Our frequency is 1 over T. So this conforms to that. So we can now calculate our speed. Speed is equal to the wavelength. What is our wavelength? 0.02. 0.02 divided by 0.04. Okay, this one is in meters, this one is in seconds. So our units will be meters per second. So this 0.02 divided by 0.04, this will be equal to 0.5 meters per second. So the speed is equal to 0.5 meters per second. So that is the speed. This brings us to the end of this video. Thank you very much for watching. If you're new to the channel, don't forget to subscribe. And if you like the video, don't forget to give it a thumbs up. See you next. Hello viewers, welcome to this video. In this video, we will be looking at the November 2016 Science Paper 1, Section B, Question 9. This particular question is on radioactivity, which is probably the last topic in grade 12. Okay, and this one is all about decay equations, and let's get into it. Question 9 reads, lanthanum 139 emits an alpha particle to form cesium, followed by an emission of a beta particle to form the nucleus of barium. Express these changes using nuclear equations. Lanthanum 139 emits an alpha particle to form cesium, followed by an emission of a beta particle to form a nucleus of barium. Express these changes using nuclear equations. So, allow me first to explain on alpha decay. So, for alpha decay, we have what is called the parent nucleus. Okay, we have what is called the parent nucleus, and the parent nucleus may be denoted as X. Okay, we have atomic number Z, mass number A. Okay, when this decay, what we should always know that an alpha particle is a helium nucleus. A helium nucleus that is denoted, the symbol is alpha, and because it is a helium nucleus, it has a mass of 4 atomic mass units and a proton number of 2. So what happens is that when this decays, it forms what is called a daughter nucleus or a daughter nuclide. Now, this daughter may be denoted by Y because we don't know the symbol, we don't know the mother, where it came from. Now, this daughter will have 2 protons less than the parent. So it will be Z minus 2, and it will have a mass of 4 less than the mother. So it will be A minus 4, then plus our alpha particle. So this is the general equation for alpha decay. This is the general equation for alpha decay. So the daughter will have A minus 4 and Z minus 2, then plus. Now let's now look at the task at hand. Let me rub. the task at hand is that lanthanum, which is La, and it has got a proton number of 57, a mass number of 139. Okay, now when this decays, the proton number 57 will reduce by 2, and the daughter is cesium, which is Cs. So 57 minus 2 will give us 55. Okay, and the mass number will reduce by 4, which is 139 minus 4, which will give us 135. So this is the cesium that is going to be formed, plus our alpha particle with 2 and 4 there. So that will be the equation for the emission of an alpha particle. Now we turn our attention to the emission of a beta. Now, which one is emitting the beta? Is it lanthanum or is it cesium? Lanthanum has already decayed to cesium. Cesium is the one that is going to emit a beta particle to form barium. Okay, now just a general understanding of beta decay also. In beta decay, the parent, okay, with the Za, what happens is that a beta particle is an electron emitted from the nucleus. Now, how can a nucleus emit an electron which is not there? So what basically happens is that a neutron is converted to a proton. Now, a neutron is negatively charged. A proton is positively charged. When this happens, there is a production of an electron to balance the charges. And this electron is what we refer to as the beta particle. Okay? So a neutron is converted to a proton. So it means that when decay happens, the daughter will have one more proton compared to the mother. So on the proton number will increase by 1. But remember, the mass number is the total number of protons and neutrons. Therefore, if we count the number of protons and neutrons, we'll find that the number of protons would have increased, but the number of neutrons would have reduced. But the total number of particles in the nucleus will still be the same. Therefore, the mass number will remain the same. And this will be accompanied by the emission of a beta particle that has a -1 there and a mass of 0. Okay, so having this in mind, we can now tackle our question. So it is only the proton number that is going to increase by 1, then followed by a beta particle. All right, so we have cesium, Cs, and it has atomic number 55 and mass number 135. This will have the daughter being barium, and the atomic number will increase by 1, so it will be 55 plus 1, so which will be 56. The mass number remains the same, 135, plus the beta particle with the -1 and 0 on top there. So these are the two equations that the examiner wanted you to deduce. All right. Thank you very much for watching the video. If you like the video, don't forget to give it a thumbs up. And if you're new to the channel, don't forget to subscribe and hit the notification bell. Thank you very much. See you next time.